Hello, everybody. Welcome. Today, we are going to talk about SOCAR Downstream APM journey, which is transformation. Journey is all about engineering reliability, mechanical integrity, and process safety across all downstream ecosystem. So our agenda is, I will basically start with the introduction and talk a little bit about downstream ecosystem and the APM transformation roadmap. Then my colleague will go into a little bit deep. We'll talk about asset criticality, safety management framework, risk-based analysis, operational excellence through APM. And at the end, we'll give what we've done through SmartSignal software, and at the end, we'll talk about our results, achievements, and our vision. So my name is Nihad Alimadatli. I work for SOCAR Downstream for 6 years, in total 11 years for SOCAR. My background is basically chemical engineering, and later on I did my master's and my PhD in corrosion scientist. I'm API certified inspector and also international welding engineer. So this is SOCAR Downstream ecosystem. In total, there are 6 assets under SOCAR Downstream management. Each has a different aging profile, and each has different capacity and final sale products target. So it was our first challenge as a SOCAR Downstream management, how we're going to utilize, how we're going to have a unique approach through for different assets has a different aging profiles. So the answer was clear for us in terms of reliability, mechanical integrity, and process safety. We had to go for APM approach. And this is our transformation roadmap, which is started in 2022. So we started to work with international consultant Bilfinger in 2022, where we start our APM initiatives in Haydar Aliyev Oil Refinery, established in 1953, as I mentioned before. And in 2023, we deployed GE Vernova APM Meridium software. And also we got the quite strong support from SOCAR Turkey, where they had a deep experience over utilizing GE Meridium software. And in 2024, again, together with international consultants, we completed 3 pilot units, all APM studies. And in 2026, we are planning to finish all the APM rollouts in all our assets. And in 2026, we started deploy SmartSignal in our carbamide plant, and also we launched PCM program, process safety management program, as part of all our asset performance management approach. And it wasn't just SOCAR Downstream doing all those studies, all those collaboration by ourselves. We deployed different international contractors. As I mentioned before, Bilfinger, GE Vernova. Also, we utilize SAP program, where all work orders, planning, spare parts, and master data are established, and our GE Vernova software also synchronized it, and we get the data through SAP to our Meridium program, and then we utilize it, and we see overall the picture. And also together with SNSD company and Icaro company, we did a lot of process safety studies like HAZOP, LOTA, risk assessment. Until that time, until we had this approach, we basically started from the zero, from the ground, and we established throughout this period. And we also closely work with Honeywell or Emerson for our digital transformations, alarm management, and emission monitoring. So when we started, again, in our old asset, we had no idea of this, what is this triangle looks like. But what we have achieved so far and what we are achieving, we are optimizing our performance cost and significantly reducing our risk. And this is typical asset performance management flowchart. Where we started, again, we started with master data and asset information. We had one unique corporate risk matrices deployed. And then we did our RCM studies, FMEA studies, asset criticality studies, and also we had the unique approach for all the units, ODR, operator-driven reliability approach. And at the end of the day, now we became the company. We are doing a lot of RCAs based on the unique methodology over all assets that SOCAR Downstream have. And we deeply analyze our reliability analytics. And we go for the now, as a next step, we are going for spare part optimization. So now I'll give the speech to my colleague, Yadigar Nazarov, who will go into more deep about what we've done so far.
Thank you, Nihad, for a great introduction. And hello, everyone. My name is Yadigar Nazarov. I'm lead reliability engineer for SOCAR Downstream. I have been working for SOCAR for more than 4 years. So it's like in the beginning of the APM project, I was hired. APM was the first interview question I was asked. And the APM was the last thing I discussed with my director before this presentation starts. So it's APM every day in SOCAR facilities. So about myself, I'm chemical engineer by the background, ASME, API, CMRP, and Six Sigma certified. So as Nihad said, we started all of our studies with the asset breakdown structure. Why? Because we know that without the strong foundation, the APM project is going to fall. So the foundation was the asset breakdown structure. Any problem with the structure will lead like a domino effect. Will lead to issues in the criticality analysis, in our strategies, operator rounds, and etc. So what we did, we took ISO 14224 as the recommended practice, and we utilized this structure in our Howard and other facilities. So what we did, we started from the plant level, then go to area, unit, system, subsystem, and then equipment level. What we achieved was the parent and child relationship and also standardization for all downstream facilities. After we concluded with our asset breakdown structure, asset register is done, we performed the criticality analysis. For the criticality analysis, the rule was simple. If everything is critical, then nothing is critical. So we used our risk matrix as the Bible, and we put all of our assets, one of these 25 cells you can see in our risk matrix. So we have low, medium, high, and very high critical equipment, and each of them have intolerable, undesirable, tolerable, and acceptable risk levels. In order to achieve the evergreening of this process, we are planning to apply the re-evaluation of our criticality analysis in every 3 years. So criticality is done, register is done, criticality is done. The asset strategy management is the next step. Here, again, we have 3 care levels: basic care, standard care, and optimized care. Basic care is for low critical equipment. From its name, you can easily understand that it's like the most fundamental level of care that you are doing for your asset. For example, it's like operator round for your big equipment, which are low critical, and also it can contain run to failure strategy if you cannot do everything for that equipment. Then it's standard care like lubrication, vibration analysis, basic cleaning task, and optimized care means that everything we have to do to keep this machine alive, but if it is cost effective. So we are taking the analysis results from RBI, SEAL, RCM, combining them together and sending to our CMMS system as a asset strategy. So it's a saying that actions speak louder than words. This is our actions in this slide. As I told you before, we are performing the criticality analysis, and it's in GE APM. For every asset that we are doing the criticality analysis, there should be the basis for assessment, so that when we do the re-evaluation of the criticality analysis, we understand why we have provided this L2 C4 level for this asset. And then we do reliability-centered maintenance, RCM, for critical and high critical equipment, and asset strategy management. In total productive maintenance, there's a saying that operator rounds are the most basic activities that you have to do to keep your equipment's functionality. And our operators have been provided with the tablets where we are designing the routes, firstly in the PNID, PFD level, then transferring it to GAPM. Then operators goes to the sites, taking the valuable information from the equipment. Then it comes to us and to operation engineers for the data analysis. If there is any need for the corrective actions, it's been done. Again, from GAPM, we are designing it, we are sending to execution, we are tracking and doing the corrective actions. So far, I only spoke about the equipment level care, but there is one big KPI that is very essential for every facilities, which is the availability. And the availability of the plant for us comes from as a result of this analysis, production loss analysis. Here we are implementing Solomon methodology to categorize our availability losses, and we are taking the lost units from the operation, and we are categorizing it based on asset, operational, and on-stream losses. And we are calculating the availability. What does it gives to us? It gives the visibility in which unit we have the most problems, and at that unit, what is our most problematic asset, the bad actors. This slide, actually, I don't want to lose much time on this slide because everyone knows what RCA is, what are the methodologies for RCA, how to perform this. Unfortunately, if we do all of the previous steps even brilliantly, it is inevitable to predict and prevent all types of failures. If the failure happens, we perform RCA for that. Our RCA methodologies are two, 5Y and logic tree methodology. 5Y is being performed for the medium critical events, and for very high critical events, we are doing the logic tree methodology. And we are using the fracas as well to keep our data alive, and also to see if the recommendations that has been applied at the site eliminates all of the root causes or not. This is all with reliability, and now comes most difficult part for me, the integrity part. The integrity, actually the steps that we are taking in the integrity is pure analogy of what we are doing in asset reliability as well. So for example, the RBI for me, this is my personal opinion, is like the criticality analysis. In integrity as well, for your static pressure equipment, not all of them are in the same criticality. So you have to do RBI in order to see the resource planning and your action planning for the future. When you do the RBI, from the RBI, you see your critical equipment and you provide sickness monitoring planning for them. For me, again, sickness monitoring is like the predictive maintenance. You go to the site, you take the readings, and you just analyze that when this equipment is going to fail, and what can we do in order to keep its functionality. And the most important one is IOW, Integrity Operating Window. Integrity Operating Window is, again, as an analogy for me, is equal to asset health. So you are taking the data from the PhD or any server, you put your higher and lower limits, and over the time you are just monitoring if the limit has been reached or not. Here, what we have done as a reliability team, we built a policy for our integrity team where if any lower or upper level, any alert or warning value has been reached, it's automatically sending the email for our process, maintenance, operation, and integrity team that this value has been reached at certain hours, and it has been reached, let's say, 5 times over these months. So how this loop is being completed, if any physical deviation happens at the site, GE APM Health Manager captures it, and if it is very consistent, then there is a re-evaluation of our RBI happens. And after the re-evaluation, the execution update in the GE APM and SAP is being done. This is like the cherry on the top of the cake for us. For our carbamide facility, we are implementing SmartSignal. Again, I don't want to just go deep dive here because we had many sessions about SmartSignal and we all know how it works. But just real example from our facilities. We have very big CO2 compressor for our urea facility where it provides the CO2 as a feed where it reacts with ammonia to produce urea. In one of our cases, our team received an alert that there could be a possible surging. So the alert created the cases, and the cases also had the trends. As a recommendation, also, it provided that there is no other physical deviation in another parameter. So it's better to go and check the level transmitter if the calibration has been done correctly or not. We went to the site, we again saw that, yes, the calibration was the main problem there. There was nothing wrong with the compressor itself. So with all of this, what we achieved so far, the biggest achievement for us was the visibility. Before APM, we didn't know what's going to come and how it's coming. But now, what we have done, we just did a bunch of incident investigation, asset strategies, asset health management, production loss analysis, and also integrity management. But with all these achievements, there are still some area of the concerns. As our facilities are very old, some of them are very old, there is a miss of inspection history and also maintenance history, which leads to some type of concerns in our reliability analytics. Also, master data for old facilities. There are no PNIDs, maybe no PFDs, and also no equipment manuals for some of our equipment. What's our goal for the end of this year is to provide the complete visibility over all of our assets, the autonomous integrity, and predictive dominance over the preventative and reactive maintenance. Guys, thank you for listening to us.